All right, another smaller topic. This one will be tested for the methods as well as the specialist methods, but it's really more important for what it's going to lead us to later. So it's a concept of a cumulative distribution function. So if I've got a normal function here, f of x equals this thing, and if it's a probability distribution, I know the area under here is going to be 1. What the probability cumulative distribution is giving us is how much area have I covered at any one point. So starting here, I've covered none. All the way up to this point, it's going to be none. And then I start increasing the amount of coverage. So I'm looking at the area. So I'm sort of cutting off here, and what's the area? Or up here, what's the area? So it's getting higher and higher and higher. Now, I know that the area by the time I get to this point must be 1, because it's the whole of the area underneath this, because the probability distribution must be 1. So I've got 1 marked in here. So I've got some kind of curve. I don't know exactly what it's going to look like. It will be steepest here because it's going to be gathering the most probability in the most area at this point. But I end up with this function here. Now, this is actually something we've looked at before. And we looked at it when we first introduced integration. And I called it a capital F of x. And it is literally the integral of this up to the value of x, wherever x happens to be. So x. And I know if x is beyond this point, it's going to be 1. Below this point, it's going to be 1. And it's going from minus infinity. Again, we're not really worried about this being a minus infinity. It's wherever the actual function starts. Now, because I've got an f of x here, and I'm going to be putting an x in, that could get a little confusing. So what we usually do is just substitute out this variable. We call it something else. And we'll call it f of t dt, dt. And that's just so that we're not getting confused with variables, but it's the same function as that one. So this cumulative distribution function is literally just the integral up until that point. So let's do an example. So I've got this function here, and I want to know what the cumulative distribution function for this is. I want to know what f of x is, and it's the integral of up to x. Now the lower limit here, it says is 5. So I can put 5 in there rather than the minus infinity. And then I'm just going to sub in a t, just so I don't have x's both here and here and get confused. Except I'm getting confused and writing dx rather than dt. So integrating this, well, that's 5 t to the minus 2. So I add 1 to that power. I'm going to get 5 t to the minus 1. And over the new power, it's going to be divided by minus 1. That's the same as times it by minus 1. So I'll just put a minus 1 there between x and 5. So now putting that in, I've got minus 5 and x to the minus 1 is the same as over x, minus, because I'm minusing this one off, negative 5 over, and then putting in the 5. Now I can do a little rearranging. 5 over 5 is 1, minus minus is a plus, so I'm going to say 1, put it at the front, so instead of saying plus 1, I'm going to say 1 at the front, 5 over x. Now, why would we do this? Well, to some extent, we've been doing it already. It means that if you want to know what the probability that x is, I don't know, less than 10, then I can literally just put this in. I can just do f of